Thanks everyone for coming. My name is William Morgan, one of the creators of Linkerd. I have this very profoundly named talk called The Future of Linkerd, which may or may not live up to, those expectations, but just we'll see. We'll see how it goes. Thanks for being here at Linkerd Day. This is only the second time we've done this. If you're around for Flynn's opening talks, this is a really fun event for us, and we get to see a lot of the talks from the community and put them on stage. And then, of course, I like to at least have some time for my own ego to come up here and talk. So the talks about the future, I'm going to start by looking at the past. So the very first version of Linkerd, 0.0.8, very first public version, I should say, was actually released back in 2016. Almost 10 years ago. This was a JVM-based application built on this library called Finagle. It was the very first service mesh. This was the first time that we even called something a service mesh. Actually, we might have used that term only a year or two later. And it was sidecar free. So, you could say this is maybe the first ambient approach. We hit 1.0 in 2017, joined the CNCF, and then rewrote everything from scratch in 2018, which is a terrible idea. I'd never recommend doing that. But the outcome was quite good, I think. And then, we kind of did our final 1.x release in 2022. And if you look at you guys, is the mic okay, or is it cutting in and out? Okay, maybe it's just my own ears. If you look at the kind of the pattern of the major releases since then, we kind of have this, not quite 100%, but we kind of have this model of we'll introduce a bunch of features, and then the next release we'll do some refinements, and then we'll introduce some new features, and the next release we'll do some more refinements. And I think that pattern has worked pretty well for us, because a lot of what we do, in addition, of course, to creating the beautiful features that you crave, is we listen, and we try and understand what's actually happening in production when you run Linkerd, and then what can we improve about that experience. So you'll see this cycle kind of probably continuing. The upcoming 2.18 release, which should be out this month, is called the Battle Scars release, because it's kind of it fits into this exact model. So here's like the preview of the blog post that you're going to get to read in a couple weeks. The theme of this release is Battle Scars, features updated functionality to reduce operational pain in response to real-life hard-won lessons we've learned with our customers and adopters who have pushed the limits of what Linkerd can do. Some of you are in this very room and you have felt the pain with us, and you've channeled the pain to us. So we're all kind of like in this together. What I thought I would do, since we're talking about the future of Linkerd, is kind of talk about this, at least briefly, this idea of complexity and simplicity. So way back in, before Linkerd was even a glimmer in anyone's eye, Oliver and I listened to this great talk by Rich Hickey, who's the creator of Clojure, called Simple Made Easy, and he kind of went into this explanation of what it means to be simple and what it means to be complex for software. It's what does it mean when we say, okay, this software's simple, this one's not, and how is that different from saying something is easy? Like, what's the difference between easy and simple? Great talk, you should listen to it. The one takeaway that I'll, and it kind of has informed everything that we've done with Linkerd ever since. The one thing that, I took away from that is there's this idea of the knitted castle versus the Lego castle. And here you've got the visual illustration. In both cases, these kind of do the same job, right? They're castles, they protect whatever's inside, they defend you against the intruders. But one of these two is really easy to modify and update. And one of these two is really, really hard to change in any way, right? And I think that's a pretty visceral, example of what it means to build software in a way that's simple versus complex. And those ideas have always kind of formed the basis of how we've built Linkerd, how we've designed it, how we've decided what to do, what not to do. You can see those, this kind of phraseology appear over and over again. Anytime anyone's writing about Linkerd, they like to write about operational simplicity or operational complexity. But I realize we've never really dug into, what does that actually mean? So without consulting anyone, and probably, this needs some fine tuning and revision. When I think about the decisions that we've made in Linkerd over the years, it's kind of these 5 core ideas to what it means to be operationally simple versus operationally complex. I said 5 commandments because I want to feel powerful, but they're really not commandments. This is just me making stuff up, right? And so the first one is do no harm. This was a very important idea for us early on with Linkerd, which is if you have a functioning Kubernetes application and you add Linkerd to it, the application should continue functioning, right? Sounds simple, incredibly hard to do, and I'd say we probably achieve it 95% of the time in practice because there's a lot, there's a lot to doing it. But, wow. Do no harm. But the opposite is not really okay, right? We can't say, well, we can't get to 100%, and therefore there's no point in even trying. We've got to do this to the maximum extent possible. Second one, this is a big one for us, be predictable. You should be able to understand as the poor bastard on the other end of Linkerd that's like stuck running this thing and operating it, and on call for it and having to wake up at 3 a.m. when it's running, you should be able to understand how Linkerd works, and it should be predictable, and you should be able to build like a mental model. Make it obvious, that was another big one for us. Let's not have wizards, let's not have magic. Well, I'd rather give you something that has 2 clear steps that are self-contained and logical and self-consistent than 1 confusing step that kind of does everything for you, right? Scale config from 0, that's another good one. And it kind of ties to the do no harm. You should be able to start, the easy things should be on by default, and then as you tailor Linkerd to your application, you can then do config, hopefully that scales like sublinearly. To get the basics working, you shouldn't have to do any configuration. And then finally, just act normal. That's what my parents told me all the time. We should look, feel, and act like the rest of Kubernetes. So if you are a Kubernetes operator, then Linkerd should feel very, very familiar to you. You shouldn't have to learn, to the extent that we can kind of avoid this, you shouldn't have to learn a whole new model. We should fit into the Kubernetes model. So those are the 5 observations. And so what I want to do next is kind of take you through a case study of one feature or challenge that's kind of evolved over the years, which some of you are painfully familiar with, which is detecting or determining, I should say, the protocol of a connection, right? So Linkerd, kind of in this diagram I have down there at the bottom, you've got one application which talks to another application. We've got these 2 proxies in between, right? And on each side, there's like the server side of what Linkerd does, and then there's the client side of what Linkerd does. Right, the server side receives a connection, and the client side sends one out. Okay, so Linkerd acts kind of classically in the classical sense of both a proxy and a reverse proxy. Now, one really important thing that Linkerd has to do is when you open a connection to it, it needs to know what protocol that connection is. We don't need to know, totally, the exact name, but we need to know basically whether this is HTTP or not. Because if it's HTTP, including HTTP2 and gRPC, then we have to do a bunch of extra stuff. Like there's some features that only apply in that situation, right? And this actually needs to happen on both the inbound and the outbound side. So inbound is I'm getting a connection from the outside world, and I need to relay that to the application that I'm standing in front of, right? That's kind of the reverse proxy case. And then outbound is I'm getting a connection from the application that I'm in front of, I being the proxy, and I need to relay that to wherever the destination is. Does that distinction make sense between inbound and outbound? Okay, so I need to know, Linkerd needs to know what protocol the connection is on both sides, because for outbound connections, I might need to apply HTTP-specific routing logic. If I don't know the connection is HTTP, then I'm not going to be able to do that. Similarly, on inbound side, I need to apply I might need to apply HTTP-specific authorization policies. And if I don't know what the protocol is, then I'm not going to be able to do that. All right. Question for the audience. Linkerd maintainers not allowed to answer. Where in this diagram does protocol detection happen for outbound connections? Anyone want to venture a guess? Proxy 1, server side, client side. Proxy 2, server side, client side. William Rizzo. Proxy 2, client side. That's your answer for where protocol detection must happen on the outbound side. That is 100% wrong. That's as wrong as possibly could be. Leave. No. But thank you for guessing. So it has to happen on the server side of Proxy 1. Proxy 1 is handling the outbound communication in this case. Alex, am I getting this right? Oh, God, OK. Didn't consult anyone before doing this, so this is terrifying. OK, let's do this. Hopefully this one will be easier. What about on the inbound side? Where does protocol detection have to happen on the inbound side? Remember what inbound is? Inbound is, I'm the proxy standing in front of an application. Connection's coming to me. Where does protocol detection have to happen? Yes? Proxy 2 server side. You are 100% right. Wow, nice work. OK, so the protocol detection has to happen on the server side, right? This is a server-side activity. In fact, it's even worse, which is Linkerd cannot even establish a connection to its destination until protocol detection has happened. So connection happens. We're trying to determine the protocol of this thing. I can't even open a connection to the destination. Why is that? Anyone want to guess? I'll give you a hint. Yes? Yeah. Yeah, that's right. That's right. So until I know whether it's HTTP, I don't know whether I have to apply this specific routing logic. So if this is a TCP connection, then I don't. If it's HTTP, I might have to look up a whole bunch of stuff. So I can't even establish, I don't even know where the connection is going to go until I've done protocol detection. OK. So what are our options? So let's go back to Linkerd 2.0, the very first time we're tackling this. Number one, we can have the user configure it. Right? You have to tell us a protocol for every port in your application. Or number two, we'll detect it automatically. Of course, we prefer option number 2. Right? We don't want to require you to do config. And if we require you to do that config, then we'd break your application as soon as we put it in, because we wouldn't be able to apply these features. OK, so way back in Linkerd 2.0, we started with one of the very first features introduced was automated protocol detection. This allowed us to drop in Linkerd into any application. And it should basically just work. Right? You read how does it work? Well, it's not rocket science. Someone establishes a connection to you, read the first few bytes, and if it looks like HTTP, then you're like, all right, great, it's an HTTP connection. And if it doesn't, then you're like, OK, it's not. That makes sense? And luckily, HTTP is not that hard to determine. Like, once you've read a handful of bytes, you're like, oh, OK, it's probably HTTP. All right, now, of course, the first problem we ran into here was sometimes those bytes would never show up. So some protocols assume that you establish a connection first, and then the server sends the bytes to you. OK, so we establish the connection. We're waiting for the bytes. We don't even know how to establish a connection to the server. And those bytes never come. OK, and these are not obscure protocols. These are SMTP, MySQL, Redis. There's a handful of these, actually a fair number. OK, so how do we handle this? Anyone want to guess? Don't detect it. OK, yeah, but how do we not detect it? What's the most annoying error from Linkerd? What Linkerd error message sucks the most? 403. Actually, yeah, that's a good, yeah, that might be true. Alex, you want to volunteer an answer? Protocol detection timeout. Have you ever seen these? Ugh, most annoying aspect of this product. All right, so how do we, that's exactly, I mean, but that's exactly the answer, right? So you put a timeout on it. So connection gets established, you wait 10 seconds, and if you don't see any bytes, then okay, you're done, right? We'll just assume that's going to be TCP, and we'll move forward with like the rest of the connection. So your worst case here is a 10-second delay, but it's a 10-second delay in connection establishment. So maybe it's not that bad, right? You can send a bunch of requests. Once the connection has been established, like everything, should be fine. It's not great, but it's fine. Okay, so that brings us up to like 6 years ago. So now fast forward to Linkerd 2.10. We've got this genius idea, which is we're going to make it easier to avoid these unnecessary protocol detection timeouts in the case where you know that this protocol is a server speaks first protocol, right? Or for whatever reason you don't expect protocol detection to ever detect an HTTP connection. So prior to Linkerd 2.10, our advice was use skip ports, which literally uses IP tables so that the connection never goes through the proxy. In 2.10, we introduced opaque ports, and opaque ports would basically say, this connection, if it was marked as opaque ports, don't do any protocol detection. Assume it's TCP. Don't wait 10 seconds. Just go, right? Just go. So now you can mark all these weird protocols. The other thing you could do, by the way, is you could TLS those communications, because TLS actually turns it into a client speaks first protocol. All right, so it sounds like we have a problem, a solution to this problem, but unfortunately, after that, what we learned is that the configuration area for opaque ports became complicated itself. It's so complicated, eventually I broke down and added a flow chart to the docs for like how to use this feature. And it's probably too small to actually read. It's in the docs right now if you want to go find it. I can think of at least 3 things that are wrong with this. First, like the fact that we have to have a flow chart already means this thing probably sucks. Number 2, sorry, I shouldn't be so dismissive. This is like years and years of sweat and effort and torture to get to this point. All right, we have this enable externals profiles annotation, which is overloaded to do, complicated things. We even added all these defaults. So we said, okay, we're going to make this really easy. If you're using port 3306, well, we know that's MySQL, and then we'll just do it for you. But adding the defaults somehow seemed to make things worse, because now you have to first decide whether this port is in the set of defaults, and if it is, then you act one way, and if it's not, then you do the other way. Oh God, I have 5 minutes remaining? Okay. Yeah, and a lot of caveats and notes, and it's just difficult. All right, but we should be good, right? I had this whole fascinating bit of history from Van Gogh. This is, 1888, he painted this picture, and then 2 years later, this is what he's painting, so that was not the end of the story, obviously. Here I am today giving a whole talk about this. Opaque ports really only solve half the problem, right? They allow you to force Linkerd to treat a connection as TCP, not HTTP. But what about connections that you know are HTTP? Why would protocol detection not work for an HTTP connection? Anyone want to guess? You got the bytes, right? No guesses. If the application or the proxy or the system is overloaded, then it might not actually send those bytes in time. Right? And then that's like the worst. This is the worst situation, because now you have a set of failures that only happen, or a set of misbehaviors that only happen sporadically. They only happen when the system's under load. And they happen in weird ways. It's hard to reproduce. It happens sporadically, and they manifest themselves as weird failures in features where the feature isn't actually the issue. Like you get an authorization deny from a policy. Why would you get that? I don't know. It only happens sporadically. It's because of this very, very complicated situation where we don't get the bytes in time. Okay, horrible. All right, so in Linkerd 2.18, we're going to introduce protocol declarations, which is, a fancy term for, well, just tell us what the protocol is, and we'll use that protocol directly. So this will be kind of a way to this is a super session, I guess, of opaque ports. So you'll be able to mark a port as HTTP 1 or as HTTP 2. We're going to use this app protocol field, which has been in the server resource since Kubernetes 1.20, so shortly after Linkerd 2.0 was released, but it's still a pretty long time ago. And in this case, we can, we'll now have the ability for you to configure it and to say, hey, this is actually HTTP2, and like, regardless of what happens, treat it as such. We actually have to be a lot more sophisticated. There's fun stuff I'm not going to get a chance to talk about here. Every pair of Linkerd proxies actually talks over HTTP2 in this kind of like it's got its own kind of pseudo protocol using ALPN, the ALPN feature of TLS, and so we can kind of pass this metadata information. So once the proxy on the left-hand side knows the protocol, we can actually just send it to the proxy on the right-hand side, which is great because the proxy on the right-hand side doesn't necessarily know which configuration to look up. We added a whole bunch of metrics here to capture this, to capture every aspect of the behavior here. So now when this starts happening or when weird protocol detection things happen, now we have all sorts of interesting data. And the result is we have this much better operational model. So no configuration is required to get started still, right? You can add configuration to produce predictable behavior for systems that operate near capacity, where this sort of thing happens. When you set that config, you get consistent behavior. And it's all Kubernetes native and lots of new metrics. So we have new ways of understanding what is actually happening when Linkerd starts, saying that authorization policy is denied under high load. Okay, so finally winding up. So, that was all kind of a long digression to get to the point where of saying the future of Linkerd is, yes, it's more features, more capabilities, more bells and whistles, but more importantly, it's a continuation of this focus on operational simplicity. And if there's one thing we've learned, it's that doing it hand in hand with our adopters is critical. We do run Linkerd ourselves in production. We are on call for it ourselves. I think we're the only service mesh creator for whom that is true. However, our environment is just one instance in the vast space of possible environments and configurations and issues. So being really, really attuned to what our customers and adopters and users are doing is critical. We've learned that lesson time and time again. Every feature that we're adding has to be seen through that lens, and we have to be open to revisiting earlier decisions as we learn about the practical realities of learning a service mesh at scale. Kubernetes itself is changing. The way people are using it is changing. So none of this is static except for our focus on operational simplicity. All right, that's the end of my talk. I am giving a related talk, it's kind of semi-related, about sidecars and ambient and stuff like that. That's another big kind of architectural question for Linkerd sometime tomorrow. It's probably a nice person who will tell you when it is. You can find it on the schedule. But thank you very much. I hope that was interesting and informative, and I really appreciate you coming out to Linkerd Day. Do I have time for questions? All right. All right. If anyone dares to ask a question. William Rizzo? Yes.
Hello. Yeah, Joe Brinkman from Ernin. I had an internal question myself. When you were talking about skip ports versus opaque ports, I think today we use skip ports. It started getting me thinking, like, well, should we be using opaque ports? But I think you kind of answered that question because, like, outbound traffic to things like Datadog or whatnot, like, is not going through Linkerd today. Like, you maybe wonder, should it be going through Linkerd, or is that like unnecessary bottleneck that we're adding?
Yeah. So the answer is it depends. My general advice is if there's a Linkerd proxy on the other side, then definitely it should be opaque ports because you want MTLS, and we'll at least be able to give you TCP metrics. If it is an external destination, then there's no MTLS to be done. We do have some interesting egress metrics and egress control as of 2.17, so that might be a reason to mesh it. But I don't think it's like morally wrong to say, okay, for this connection, we're just going to like skip Linkerd because we don't need it in the mix. So it really depends on what you're trying to get out of it and like what kind of problems you're seeing. If there's a huge amount of outbound traffic, then Linkerd might need a huge amount of resources. You might decide, okay, it's not really worth it because it's not really doing anything for me.
Okay, thanks.
Yeah, great question. Thank you. Yes, William Rizzo. And thank you for
you say
thank you for taking another crack here.
So right now with FedRAMP, of course you didn't cover it, but
yeah.
Right now with FedRAMP, with the Gaia X and the sovereign cloud and all these things, do you think we start seeing different personas in Linkerd conversations, more, let's say, closer to the infrastructure side?
Yeah, that's an interesting question. I love those use cases. I don't think they fundamentally change kind of the persona who's involved for Linkerd. For me, the fundamental persona is the platform owner. As a person, whether they're called DevOps or SRE or platform or something else, it is a person who's creating the underlying platform in service of the developers. So whether that's in a FedRAMP context or anything else, I think that core persona remains the same. That's my sense. Yeah, but open to arm wrestling over it.
Thank you.
If you feel otherwise. Yeah, thank you.
I don't have a question. I'm just going to point out that William is the next speaker talking about multi-cluster, cluster API, things like that. So hang around for him.
Your chance for revenge. All right, well, that's all we have time for. Thank you, folks. Really appreciate your attendance today.